Welcome to this video. My name is Prabjot Kaur, and in this video we're going to focus on the basics. We're going to study how we take the text input and feed that into deep neural network for performing various NLP tasks. So without further ado, let's get started. As a background, first we should understand what are the various tasks in NLP. This is a snapshot from a GLUE benchmark, which consists of several tasks in NLP. So the tasks are things like checking for a grammar in a sentence, or checking for similarity between two sentences, or question answering tasks. What's common in all of these tasks is the input that we are using is text. However, the problem is the deep learning models, they don't understand text. They don't understand these continuous sentences. So we have to come up with a way to take this text and convert it into a format that the deep learning model do understand. So here, let's get started with an example. Let's say we have a data set which contains just 3 sentences. These are 3 different input samples in the data set. And we want to use this for training a deep learning model. Because the deep learning model does not understand the text, what we have to do is we have to convert it into tokens, or we can say we have to convert it into numbers, because these numbers is what the deep learning model does understand. So what I'm going to focus on this video is how do we take the raw input and convert it into a numerical format, which is what we will use to train a deep learning model. So to put things into perspective, I want to show you a BERT model. This is from one of the famous papers in NLP. It's a BERT model. So to compare, what I'm going to present in this video is, so this is the BERT model, but what goes into this BERT model is this sentences text. However, this text is not fed directly. We have to convert it into tokens, which is what these are, and that's what goes into the deep learning model. So what I want to highlight is, I'm not going to cover what's embedding and things like that. We're just going to focus on this part. Okay. Before we go through the details of the conversion that I just showed, we need to understand some of the terminology in the NLP, such as a document, corpus, and vocabulary. A document can be ambiguous term to understand, but basically this is just a single input sample. So this input sample can be a sentence or a paragraph or an actual big document. So that's what document is in terms of NLP. And then corpus is the collection of documents. And then the vocabulary is nothing but the total number of unique words that are present in the corpus. Let's say we have an example. So these are the reviews from Google, and these are the reviews for Google Pixel 7 Pro. To keep things simple, I'm just going to take the summary of the review, which is the first sentence here for each of the reviews, as an example. So then each of this review, individual review, is considered an input sample, or in terms of NLP, each one of this is called a document. And together, this is called a corpus. Then the vocabulary is nothing but the unique words that are present in the entire corpus. So this is vocabulary. As you can see, this corpus is pretty unique. Only the word features is repeated twice, but everything else is only once. Therefore, the vocabulary is all of these words, whereas the features is counted only once, because we care about the unique words. Now that we understand the terminology, let's get deeper into how do we do the pre-processing. So first of all, we have this input, which contains of 3 documents, 3 input samples. First thing that we should do to pre-process text is to remove the stuff that probably is useless for processing text. This is maybe not a good example because this is a very straightforward input for the NLP. However, sometimes your input can be very complex, where it contains URLs, contains digits, it contains emojis, or it contains exclamation marks and whatnot. So we remove all of that. And then another thing that we do is we lowercase all of the words. And the reason why we do that is because let's say you have a word the. If you have capital T versus lower t, it's the same word. Therefore, if we don't lowercase everything, then capital the and lower the will be considered as two different words, which is not what we want, because we want to minimize the vocabulary size. We don't want to have a huge vocabulary. So this is a way to minimize the vocabulary size by just lowercasing. And then we also remove the stop words. So stop words are things like and, so, but, from, on, the, with, things like that. Again, the reason why we remove the stop words is because they don't add much value to the tasks that we are trying to perform, and also it helps us to reduce the size of the vocabulary. And then finally, another preprocessing step is lemmatization or stemming. So here, let's say we have a word running and run. They are the same word, even though they represent different things, but it's the same word. So we take all of the words and we replace them with their root words. So for example, running would be replaced with run, driving would be replaced with drive, things like that. So again, all of these things, removing the stop words and lowercasing, lemmatization, they all help us to reduce the size of the vocabulary. So after we apply these pre-processing steps, what we get is we have converted our raw input to this. So as you notice, we have lowercased all of the words, and we have also removed these stop words. Other things we didn't have to do for this dataset because this dataset wasn't as complex to begin with. Okay, so now we have done some pre-processing. This is also called normalization, by the way. Then the next thing is we want to convert this continuous sentence into discrete units for processing. And that's called tokenization. Tokenization can be done at the sentence level or at the word level. In this case, we will do tokenization at the word level, and we call that word tokenization. So basically, we have entire sentence, we break this into discrete units, and those units are words, and each of this unit, in this case a word, is called a token. So this is tokenization. Then what we need to do is we have done all the pre-processing that we need to do, but where we want to go is we want to go from the text input to the numerical input, and that's where building the dictionary comes into play. So what is a dictionary? In dictionary is nothing, but we first create the vocabulary after doing all the pre-processing. Vocabulary is nothing but the collection of all the unique words that we have in the corpus. I want to point out one thing. So as you can see here, the vocabulary contains all of the unique words, but I have two special things in the vocabulary, which is U and K, which stands for unknown. Now I have something empty string. So these are two special tokens that are added to the vocabulary. And the reason why they're added to the vocabulary is, first of all, the unknown is, let me explain you a little bit why we need the unknown. So let's say you build your vocabulary, which is what you would do from using your training set. Now, when you use that, after you have trained your model and everything, and when you're trying to test on the test set, it is possible that your test set may contain some words that were not present in the training set. So that's where you need this unknown token. So any word that is new in the test set, which was not present in the training set, will be represented with the unknown token. So that's the use case of the unknown. The empty string is used for padding. So as you can see here, these three inputs, they're not of the same size, but in order to feed input to the deep neural network, usually we need to have all of the inputs of the same size. So in this case, 1, 2, 3, 4, 5. So third input contains 5 words, and the first input contains 5 words, but the second input contains only 3 words. So this input has to be padded with zeros as an example to make it equal to the size of the other inputs. So wherever we do the padding, that's where we will represent the padding with the empty string token. All right, so now we want to build the dictionary. By building the dictionary, we simply mean that we want to assign indices for each of these unique words. Again, the unique words that we have in our dictionary is empty, unknown, and best, all of these. By the way, these are also called tokens. And then we just assign indices to each one of this. Here, I just assign it indices from 0 to 13 because we have 14 words. Then once we have the dictionary, now we are ready to convert our text input to a numerical input. Let's see how we do that. So here, this is our input, and we have the dictionary. All we have to do is we have to look up in the dictionary, and we have to replace each of the word with its index. And that's pretty much what we have to do in order to get from that raw text input to the numerical input that we finally feed into the deep learning model. So just as a recap, we are given a raw text. In order to convert this raw text into numerical input, we have to go through several processes, pre-processing stages. So the first thing is we remove all of the extra things that we don't need, that don't add much value, such as URLs, special characters, emojis, digits, and whatnot. And then we can do the tokenization, which means we take the sentences and we break it into words. That's called tokenization. And then we can do pre-processing, further pre-processing, which is lowercasing, removing the stop words, lemmatization, and then we can do further pre-processing, which is simply just padding the shorter inputs with 0 so that all the input in the training data set or the test data set are of the same length. And finally, we need to build the vocabulary and the dictionary so that we can create indices for each of the unique words. And those indices are then used to represent each of the word here. And this is what goes into the deep learning models for training. So that's our entire pre-processing pipeline for pre-processing the text. Again, just the conclusion, what we studied in this video is how to take the raw text input and convert it into a discretized numerical input. And I have an example which I will paste the link here. You can just look over and I go through the entire process in that example. And then finally, I want to re-emphasize that we have not discussed things like embedding and other advanced concepts in this video. So just don't mistake whatever I explained. Please don't mistake that as embedding. Embeddings are different than what we studied here. So that's pretty much all for this video. I hope this was helpful. And if you like the content on this channel, please consider subscribing. That's the way you can help me, and I will produce more videos that probably will be helpful for you. Thank you. Bye for now.